Hi, I'm Paul. We are doing Leetcode must-know interview questions, and today's challenge is binary tree zigzag level order traversal. Um, okay. Medium difficulty according to Leetcode. And the challenge is, given the root of a binary tree, return the zigzag level order traversal of its nodes values, i.e. from left to right, then right to left, for the next level and alternate between. And they have a simple example here where if you get a tree that looks like this, they want to see the output like this. It's a list of lists. So the first list, and when we talk about levels, we're talking about horizontal levels. The first level is 3. Now we got a zigzag. So the second level, we're going backwards. 29. The third level, we're back to forwards. 15, 7. If there was a fourth level, it would again reverse. All right. Well, this is, again, the last two or three of these that we've done have been binary tree breadth first searches. Okay. Which is another way of saying level order traversal. In fact, this is the last one that we did, and it's probably close enough to what we're trying to do here that we could take the code and modify it. Actually, we're going to have to modify it more than I would really like to, but we can still save some typing here and just grab that and bring it over here. Actually, you know what? Before we do that, we should probably talk about how we're going to do this. I mean, it's still a breadth first traversal. It's just that you're going to need, or we are going to need, let me get a pen here. We are going to need a variable. We call it reverse or something like that. And initially, we can set it to false because the first time through we are not going backwards. We're going to need a queue, but really to make it work, we're going to need a double-ended queue where we can add or remove elements from either side. Normally a depth first search requires a queue, but if you want to do a depth first search and reverse parts of it, then you're going to want to be able to add and remove elements from both sides of the queue. Okay. What else? Okay. Let's work on it. Let's work on it over here, and let's say that the queue. The first thing we're going to do is put the root node in the queue. All right. 3. Sorry, I lost my. Okay. Now, are we moving forwards or backwards? We are moving forward. So we will pop. I shouldn't say pop on a queue, but we will dequeue from the front of the queue this number here, 3. And 3 will in fact be our list for level number 1. All right, having dequeued the 3, we then want to add to the queue the left child and the right child of the 3 node. So that would be 9 and 20. All right, that is our new queue. We are going to go into a new for loop. We're going to go through the for loop twice because that is the size of the queue. The size of the queue corresponds to the number of nodes in the level. All right, so we have 9 and 20, but we have to change the reverse. We have to change the reverse here. All right, this is not false anymore. We are going to go into reverse mode on this level. All right. If we are reversing, then we don't want to dequeue from the front of the queue. We want to dequeue from the back of the queue. That's the 20. So this is going to go into our array for the next level. We are going to dequeue 20 and put it here. We are going to add the right node of 20 and the left node of 20, but not at the end. We're doing everything backwards here. They're going to go at the beginning. So the right node of 20 is 7. It's going to go at the front of the queue. The next node is 15. That's the left node. It goes at the front of the queue, and we have dequeued the 20. All right. Next, again, because we're moving in reverse, we're going to dequeue from the back of the queue. It's a 9. All right, so that goes here. 20 and 9. There are no child nodes of 9, so there's nothing else that we have to do. That finishes the loop for the second level. So we have the list for the second level, and again we flip the reverse. Okay, we're going forward. Now you can see what's going to happen here because there's only 2 elements left in the tree. There's only 2 elements left in the queue. We're going to take them off, and the third list in our output list of lists is going to be 15 and 7. So that said, now we can go ahead and try an implementation. All right, I copied that code from the previous level order traversal, and I'm going to paste it in here. List integer, yeah, you can't really see the input here, but that is root coming in. So we get the root of the tree, a pointer to the root of the tree coming in. All right. Actually, well, you know what? I can scoot this over and we can like see more things at the same time. All right, so we still have the list of integers. That's still what we're going to return. We still, I think, let me look at the constraints here. Constraints, the number of nodes in the tree is 0 to 2000. So yeah, it is possible that the root node coming in will be null, in which case we'll just return the empty list. Do they have that as an example? Yeah. So if the root comes in as empty, then the output is also empty. All right. Tree node. Q. That can't be a Q anymore. We really need that to be a deck. Okay, and we could leave it as a linked list because a linked list does implement deck, but I would rather do it as an array deck. To me, it makes more sense. All right, and then we have Q, add, root. We have, all right, while Q is empty. Right, so you queue up the root, and we're going to keep going here until the queue is empty, which means that we have processed the whole tree. We'll get the level size, which will correspond to the queue size. We need a list of integers, array list. We'll have one for each queue level. And then we can say for I equals 0. For I equals 0. Yeah, okay. So we'll have a for loop for that. Now, we're going to have to do, multiple tests here to determine whether we're going forwards or backwards. But first, let's define this tree node. I need to define it outside the if statement that we're about to write here. If we define it inside the if statement, it's not going to be visible anywhere else. So let's say we've got a tree node, and if we are going in reverse, let me just copy this. If we're going in reverse, then we want to take the node from the end of the queue. So we saw an example of that. The second level, we're going in reverse. So we want to take it from the end of the queue. If we're going forward, we'll go ahead and take it from the front of the queue. Why did that go way over there? Oh, I see. Right here. All right. Add the node value to the current or to the array for the current level. All right. Now, again, because depending on whether we're moving forward or backward is going to determine whether we add child nodes to the front of the queue or the back of the queue. We need, oh, wait a minute. Whoa. If level size equals 1, yeah, no, we still need to do that. If we have reached the last node in the level, we want to add it to the result list. So let's do it after that. Let's say if reverse, then I'm going to need two of these, right? Actually, I have two of them. If we're going in reverse, we put the right node in first, right? Okay, that goes there. If the node right is not equal to null, we will add it, but we add it at the beginning. And same with the left node. add first. Okay. Tab that in. And then we'll say else. And we'll do almost the same thing. I probably should have left the original. There. If we are not reversing, then we will do what we did in the last challenge, and we will add the nodes at the end in this order: left first and then right. So if node left is not equal null, add, just say add. We could say add last, but it does the same thing. Okay. And then one more thing. And that is at the end of every level, we have to flip the reverse variable. Did I find that somewhere where it's visible? Actually, I didn't define it. Actually, I didn't find it. Yeah, okay, so that's not good. Let's define it here. Boolean reverse equals initially false. Does this look any better down here now? Reverse equals not reverse. I think it should be okay. Let's try and run it. See what happens. Compile error, tree node, variable, right. So I defined it outside the if statement, so we don't need to say tree node here. All right, anything else? Okay, let's try it. Accepted. I mean, I'm pleasantly surprised because some of this reversing stuff, not sure I got it all exactly right. All right, so that did work. Okay. Yeah. So again, breadth first search. I think the first thing, probably the first breadth first search challenge that we had was just a basic breadth first search, and then we've had some variations on breadth first searches, but the basic idea is if you want to do a breadth first search or what's sometimes called a level order traversal of a binary tree. You can do it with a queue. Just put the root node in the queue, dequeue the root node, put the root node's children in the queue. Again, dequeue the first node in the queue, put the children in the queue. Keep doing that until you've gone through the whole tree. There may be some variations on that. The ones we've done previously have been pretty simple. This one is a little bit more. I don't know. It's a little bit more. The only word I can think of is it's a little bit more confusing to me because we have to reverse parts of the answer. So we need to keep a track of that and write the code accordingly. But it's still a breadth first search with a queue. So, okay. Hope you enjoyed it. Please feel free to like, comment, subscribe, and see you next time.